here editing today's video. It's the 18th of February. It's a video about doing this side of this piece here for the fixture, for the 5-axis mill stop fixture, with the fixture to make this on. And I just want to say that I did a little thing for Hacksmith, one of these kind of things. This is one of the parts, an extra one. I actually have 2 extra ones in case they need it. I made them because I had to, make extras to get the shots of the video I wanted. But I want to thank all the new subscribers that got me. Wow, that like, well, I don't have that many subscribers anyway, but that kind of doubled my subscribers. And so thanks to the new people from the Hacksmith channel. I don't know if you like machining videos, but maybe you just subscribe because I did something for them, and I kind of hope to do more in the future. We were talking about a EDF impeller thing. They haven't finalized their design on it yet, so I don't know yet on that, but I would certainly like to do the machine work on it if I could. And just trying to get this video done so I can upload it to YouTube on this piece here, and then we're going to make the other side of it. Someday I'm going to get to this mill stop, actually doing it on this fixture so they can see how that works. But right now, got to build the fixture first, So all the new subscribers, thanks for subscribing. Oh, I got this. Finally got this Mavic Pro thing, and I've been like waiting 4 months for this thing. I didn't really get it for the purpose of this channel or these videos. I am building a small hotel-like place in Mexico, in the state of Guanajuato, in the city of Guanajuato, Mexico, and I want to take this thing down there and do some aerial shots of the building and the area. So that's really what this is for. But man, this thing is incredibly easy to fly. I've flown RC like since I've been a teenager. I'm not really that great at it, but I'm alright. But this thing is like anybody can fly this Mavic thing. They really, the technology of this, now, this I'll unfold it so you can kind of see it better, but this is what it really looks like. This thing is, anybody can fly this thing, believe me. So if you're looking for a drone to do video with, or just like to fly drones, you might want to look at this. This is really a nice drone. Look at how small it is too. Man, this thing is tiny. I mean, it's like, that's my hand, and that's the drone when it's folded up. This is a pretty neat deal. And it takes forever to get one. It did for me, but I'm not some big shot on YouTube that gets it like given to me. I had to buy it, but it took over 4 months to get this thing since I've ordered it. I was playing around with it yesterday, and like I say, it's really easy to fly. Here's a little clip of my first flight of this Mavic drone in the backyard. Just a little clip here, and I'm telling you, this thing, this doesn't have anything to do with the video, but I just include it just so you could see. I'm flying it in my backyard. My backyard is very small, and I just circle around in the backyard. This thing is that easy to fly. This is, I'm not kidding, this is the very first flight that I ever did with it. It's that easy to do. Just circle around. It was a little bit, it was almost raining. You can't really tell in this video, but it was almost raining, and when I got up a little higher, the wind was blowing kind of strong, so I came down lower and circled around the backyard here, just filming the thing with the camera on it. I think I had this set on a
HD video. It can take 4K video, but I set it on just HD 1080, I think it was P, and at 60 frames per second, I believe this was. But when I got up above the roof of the house, the wind was shaking it around pretty good when you're watching it, when you're flying it, but you can't see it in the video at all. That the stability thing on the camera, that gimbal on the camera, really steadies the camera out on this thing. See, over here, I think I go up high again, and it was like I don't know, the wind was kind of buffeting it around quite a bit. You could see the drone moving, but in the video you really can't see it at all. It looks perfectly steady. I don't know if you can see those trees in the background shaking around. The wind wasn't real strong, but it was a little bit. I don't know how fast, but it was enough that I could visibly see the drone moving around due to the wind, but you can't tell from the video. Anyway, that's just me playing around with the drone. Very first flight with the drone. And I do have it set on the beginner level here. I think I'm going to leave it there until I get used to it, but it really is that easy to fly. I have to get used to, you know, moving the camera up and down. That's my wife Margaret coming out of the back door of the house. So anyway, that's a little clip of the drone's first flight in the backyard. It was pretty close to getting dark too here, so it works pretty good in low light. This was, I don't know, maybe about 5:30 in the evening when I took this shot.
I already indicated this, but just to show you, I got it straight in the x-axis. And I checked it vertically this way and the keyway, and they were all within a half a thousandth, so I'm going to let that go like that. And now we're going to probe the part 0 of the part. And I already made the entered the little macros in the MDI. It's the same thing we did before, actually, in the last video. We got to get we're going to do the X on the center line of this, the key slot. That's going to, you know, ultimately fit in this table slot over here, actually, when the thing's mounted. Okay, this is going to set the G54 offset number 1 in X. Okay. Jog it around here and set the Y. The same fixture offset G54. Get up in Z and get it over here. I'm gonna put it, well, kind of approximately where the bearing bore is gonna be. Maybe right around there somewhere. I don't know. It's about where the bearing bore is, more or less. It really doesn't matter, because I already indicated the top of this, and it was all within oh, less than 1/1000th of an inch. I'd faced it on my horizontal mill over at the bigger shop, just squared this block up, and it seems pretty good, so I'm not going to reface it. We'll set the Z offset here. And that's good enough for that. Now I got to go to the computer, make the program. Like I said before, we're going to mill this off so we get rid of these two pieces of material here. And we only have to go down this deep where we left off before. Get rid of those, and then we're going to finish the OD with a longer end mill, and we'll rough out this bore, and then we're going to set up some boring heads and bore it. Which I got to mount this onto this shank, this ITS boring head. This is an ISCAR ITS boring head, but it's really made by D'Andrea. They call it ETM. I don't know if you can see that on the screen there. I'll explain this in more detail when we get to it, but these are really nice boring heads. I use them at work on the bigger machines quite a bit. Expensive, but they really work good. Every one of those divisions on that dial is 1/10 of 1/1000th on the diameter. So one revolution of that dial only changes this slide 4/1000ths of an inch on the diameter, or moves it only 2/1000ths of an inch actually on the radius. These are excellent boring heads. I really like them. We have to set up a couple of more tools to run the program. This is the first one. This is a 1/2 inch end mill. It's actually tool number 6, and we're going to touch it off to the tool setter here. This is the tool that we're going to finish the OD with. It's a 5/8 5 flute end mill. We got to touch it off as well on the tool setter. Okay, here's the boring head we're going to use to bore the holes, the counter bores for the bearing races. So we got to jog it down, manually touch this tool off the boring head because it's not, the insert isn't on the center line of the tool, which is the way the standard tool setting macro works. So you got to use a different one for this. So here we go. now we have to set the boring head's diameter rough set it. So I'm going to jog it down in here. I stopped the program. So I could adjust this. What you want to do is adjust it so it barely starts to take a cut on this diameter. I could have set it on the tool setter, I guess, at the other shop, but I didn't have the shank over there. So I'm going to offset this. So just get a cleanup cut on here. Right now the bore's about 20 thousandths undersized or 10 thousandths stock on the radius. So got quite a bit to work with. Taking a very light cut on there. We're bringing up the 0 on here. I'm going to manually take a little cut in there. Just see kind of where we're at. Like I hardly cut anything. Pretty good. Should be way undersized. And we're about 20 thousandths under. I'm going to crank out a little bit more. Another revolution, which is 4 thousandths on the diameter of this. Back up a little bit with this camera here so we can see what's happening. 4 thousandths on the diameter. We'll see where we're at. Okay. Tool 8. I didn't really use a boring cycle on this because I'm not too worried about a spiral scratch pulling out. This should be right on the money if everything was right. Got about 2/10. Just about right. It's about where I want it. A couple of tenths bigger than the actual size of the race. See how this kind of fits in there. Some shading. I think that's going to be good. That's going to tap in there. See, this set of gauge blocks was set
the bearing rings, but it's kind of drags through there a little bit snug. I mean, it doesn't just fall through there. So that's acting like that's going to go down in there. Perfect. Okay, I'm happy with that. So now we got to just clean up the mess again. Part of machine work. I think 50% of machine work is cleaning up the mess to do the next thing. And we'll flip the next video. We're going to flip this part over, and we're going to rough out this counterbore for the bearings on the other side, the bearing, and then we're going to carefully indicate this after we, we're going to set the zero the same, but then we're going to carefully indicate this bore to make sure we're dead nut on that bore instead of just maybe, this is supposed to be exactly 5 inches from the bottom of this to here, because that's the center height of the rotary table over here. So, but what's more important on the other side is to be exactly concentric with this bore here, rather than just exactly the 5 inches or whatever, because that way the bearings are going to run true to each other. So that will be the next video after this one coming up.